Yo, what's up, you guys? Let's see. I'm just setting up my webcam, obviously. And I will go up a little bit. What's up, you guys? Look, if you're in the chat, definitely hit me up. Let me know you're here. Dival should be coming here any moment, and we'll get this live stream on the way. This is super exciting. Dival is really awesome. He's one of my really great friends. He's an awesome engineer. What's up, Preston? How's it going? Fluffy, how's it going? Yeah, so Dival's one of my good friends. He's starting a 3D printing metal company, 3D metal printing. So it'll be really exciting. He recently left to start full time on this, and he's going to be moving to California soon. So this should be a fun conversation in general. Yo, NASJAQ, I love your TikToks. Thank you, Spade Demon. I really appreciate that. And yeah, Dival will just be here in a few minutes. So I sent him a message. I don't know, he'll jump on. Spade Demon, I really appreciate that. I really appreciate the support from all of you guys, especially as I'm starting this podcast thing. So seriously, I can't say that enough, honestly. I'm going to edit the description of this podcast to include the Anchor link, which is where you can find the full podcast as well. Actually, it should already be there. Will podcasts be regular? Yeah, I hope the podcast will be a regular thing. I want to do, at least until I hit like 10 podcasts, I want to do one every day, every other day. So that means that, by the end of the month, hopefully I'll have 10, 15 podcasts completed. Dival, what's up, man? Hang on. I'll turn on your screen in a second. Let me just double check one last thing before we go live. Okay, cool. So we got the proper video description. So the podcast link is in the bottom in the description. And now I'm going to bring Dival on. And Dival, what's up, man? How's it going?
How are you doing? I'm doing great. How are you doing, Jack?
Yeah, good to see you, man.
Awesome.
Thanks for taking the time.
Yeah, absolutely.
Are you still in your workshop right now? Or where are you at?
Yeah. Well, it's my parents' basement, but I've kind of turned it into a workshop.
I love that. I love that so much. Here, hang on. Let me just go grab my hat. So I'll edit this to start at a better point for the actual podcast. Okay, cool. So I just posted a TikTok, so we should have some people on, but basically we'll just do this, promote it to Twitter and everything, and there we go. So cool. Dival, what's up, man? You are starting a 3D metal printing company. You recently left, university to pursue this. You also had a job, and now you're doing this full time, and that's super exciting. Yep. That means that your startup Vucasan is starting to take off, and it's time to build. So
yeah, absolutely.
Yeah. So tell us a little bit about your company, your background before we get into everything.
Sure. Yeah. So Vucasan is how you pronounce it. I feel like a lot of people just don't know how to pronounce the name. It's kind of hard to pronounce, but yeah, we're basically building a metal 3D printer that's very similar to the plastic FDM printers. So we're building a printer that prints metal like plastic. So it takes like pure metal wire and just deposits it through a nozzle, and it goes layer by layer.
Mm-hmm. And that currently is not obviously possible. That's like super difficult technology.
It exists, but I would say that quite a few of the methods out there are pretty low print resolution. So it's not that it doesn't exist. It's just like not good enough to be useful in most cases.
Okay, cool. So before we get into the startup, I kind of want to get a little bit into your background. So you recently left to start doing this full time. How did you, like, what was your experience with startups beforehand, and how did you realize that, it was kind of time to take the leap and start this startup and really go full time?
Yeah. I would say that I really became aware of startups when I was 15 and I ran a robotics team in high school. I realized I was so bad at running it that I needed to learn how to like lead a team. And
Yeah.
I came across some Elon Musk interviews, and I read his biography, and kind of that's how I kind of became like aware of the idea of startups at all, because I live in Ohio. Um, and so it's very different. But I got on Twitter basically, just started following a lot of startup people and just like a lot of YC type people, and that's where I started to really learn a lot about startups and just going through and reading about things. Pretty much everything I learned was from Google, YouTube, and just like following people on Twitter and DMing them.
Mm-hmm. And so you were at your robotics club in high school as well, and so that was kind of where you like sharpened your engineering skills.
I'd say that's where I kind of started, or really started. I was really interested in like Arduino, and actually, what really got me into coding was Roblox as a kid.
Okay.
It's like about 10 years ago, nearly. So that's how I like really started out. But the robotics team made me realize like, oh, I can actually like run a team, because I always viewed myself as like just someone who wanted to just do the technology and just like focus on engineering, and didn't really care much about like people really. To be honest, like I didn't want to deal with like managing people at all. But I realized through the team, like, well, that's where I can have a lot of leverage and like really, focus on solving problems by just like directing like people to do this, or like focus on this particular problem, and just knowing what to focus on.
Totally.
So I would say that's kind of where I got started. And then when I went to University of Cincinnati for a bit, as a computer engineering student, I joined Hyperloop as a freshman and got really involved in the Hyperloop team. And we were competing like in the SpaceX Hyperloop competition. Like the goal was to make this like student pod, and it would run down like this mile-long track in a vacuum tube. And we were like one of the top 20 teams there, and so it was like really cool to be out in SpaceX and like see all those people. And
don't worry, I definitely want to talk about the Hyperloop project that you were on.
Yeah, and so I led electronics there, and helped start the electric racing team as well. So I not only like the robotics team was really small and had a small budget, so it was like switching to something that's a bit bigger scale. People who are on the team like actually have worked at other places and like have some professional experience. So managing that kind of team and like really focusing on like solving problems there and just building the pod and dealing with all the chaos was a lot of fun. So I learned a lot that way too. And I think that like really for me, I learned more from like student engineering teams than anything else, like in terms of like classes or anything.
I think that's like a common theme between engineers that are among engineers that are building anything, is that you learn so much more by actually building a project rather than sitting in classes and listening to theoretical stuff.
Absolutely.
Of course. So I want to go back and what were you making in Roblox? Because that's very funny. It's almost like a meme that people learn to code through Roblox, but you actually did.
Yeah. There's this really popular game called Base Wars. I don't know if it's popular now. I don't play Roblox anymore, thankfully. But yeah, so I was kind of making like this Base Wars clone, and Base Wars was like this first-person shooter, and they had these like colored bases, like yellow and green, and it was like this map that you played in. And I wouldn't consider myself like a coder at that point, but like I was able to like find other people's work, copy paste it, like change a few things, and like play around with scripts. And that's what got me comfortable with computers and just like tinkering with things.
Mm-hmm. Yeah, I mean, so that's a mindset, and especially you need to be able to build that. You need to have that mindset really to get anywhere in engineering, I think, just to be able to say, you can't build everything from scratch, of course.
Right, absolutely. Yeah, I think that's where I kind of got into it. And then at the same time, I was really like obsessed with Iron Man. And so I was like, particularly like how he flew. And so I came across like a bunch of videos on like people making mini like gas turbines and jet engines out of like Coke cans and soup cans and stuff, which they don't really work. But at the time, I was still pretty young, so I couldn't tell. But it was still fun to like just mess around with that. And so I became super obsessed with that for a while.
Kind of what that guy on TikTok's doing now. He has like 2 million followers. I forget what his name is exactly, but he's basically flowing some gas and igniting it through a Coke can, essentially. But you
Yeah,
made it with those
yeah.
prototypes. Nice.
Yeah, I built it out of sheet metal, and I knew that hot glue would melt. It's not that I didn't know it would melt, but I used it anyway because I didn't know how to like, connect different sheet metal parts together at the time. Like other
Wait,
than
so when
bolting
you were
them.
building it out of sheet metal, like how big was it? Just around your arm, or are you saying like a full body Iron Man suit? Like you were this
Oh,
obsessed?
so I started with like a little jet engine type of thing. It was like this big, like maybe the size of my head.
Okay.
And I like went ahead and like, I saw like different diagrams of jet engines and like just reading through like the NASA website, GE website, and all those things. And I got like some sheet metal cutters and like just sheet metal from Home Depot and started cutting out the pieces and like bending it into shape with like pliers and stuff. So it's really scrappy. But
That's awesome.
yeah, I started like that. And then, at the
What
same
was that
time,
kind of your first foray into mechanical engineering?
yeah, I would say so.
Okay.
And
Sorry, yeah, go ahead.
yeah, so I was like I was doing that, and then at the same time, like I was just trying to learn how to make more things. So I was like reading up on Instructables, which was like I'd say it was like one of the big like DIY websites at the time.
Mhm.
And so I really started just like seeing other projects and like kind of learning from, oh, you kind of connected this motor here with this like circuit, and then I found this thing called Arduino, and Arduino is like this huge game changer because you could like write, because I didn't know what a microcontroller was or any of that stuff either. It's like, oh, this Arduino is like, I can use it to control motors with code. And so I came across that, and then actually now that you asked about the suit thing, I did for a year after that, like for a science fair project, what my project was making this like robotic arm that you could wear. And it had like a servo at like the elbow. And it was
Nice.
controlled by an Arduino. So yeah, I didn't go to the full suit, but I was pretty obsessed.
Would you say Iron Man was definitely like one of the more influential things or characters or people that got you into engineering, or like was it Iron Man and then maybe it transitioned maybe into Elon Musk after you read the biography
Sure.
and that got you into startups, or like who else was influencing you, or what else?
I'd definitely say my dad early on. My dad worked at Bell Labs for a long time, and he's an electrical engineer. So that's like where I kind of like was aware of what engineering was, but he was also like he's a specialist and really focused on a few things, like particularly with FPGA stuff and digital electronics. So like if you go ask him like mechanical engineering questions, he's kind of clueless.
He could maybe help you with Arduino, but not the sheet metal.
Yeah, I mean, he didn't. Yeah, he didn't really know about Arduino or anything. It was just like, actually, whenever I'd ask him, like, "Hey, can you help me with this?" and he's like, "Just wait till college, and they'll teach you there."
He's too deep on FPGAs. He's too deep on FPGAs to be helpful.
Yeah,
but that's awesome because then it made you
Yeah.
be like, okay, I guess I gotta teach myself and like learn.
yeah,
and
yeah,
do it myself.
absolutely. And so, yeah, I think that's kind of like where I got started, but and just thought of, I think I was like 4 or 5 when he brought like one of his boards home, and I got to see it, and it's just really cool. But then like when I saw the Iron Man movie, I was like 8, and it kind of opened my mind to like, oh, people can like, you can learn how to build everything, at least fictionally. And then
Absolutely.
and then with Elon was like the first person that came across that like could kind of do that in real life, like where you could be this generalist engineer, because at the time I didn't know what a systems engineer was. So that was like the first like real role model for that.
And then that kind of pushed you into the Hyperloop competition as well.
Yeah,
So
absolutely.
So that was like, is that Hyperloop competition also when you got to ask Elon your question?
Yeah. So I guess to fill everyone in, so at the Hyperloop competition, actually, Elon showed up and did like a short Q&A, and I got to ask him a question. And I was really just looking for like startup ideas or like spaces that'd be exciting. So I asked him like, I know Elon, you're like really busy. What's some technology that you're really excited about, but you don't have time to pursue? And he's brought it up in the past, but he said, I'm really excited about doing a supersonic electric jet. It'd be great if someone could do it, or something like along the lines of that. And then he went into the physics required for like the energy density of the cells for like an electric supersonic jet to be like practical and cost effective to compete with like your traditional jets.
And
So,
so after that question, did you start like considering it, or did he kind of talk you out of it with his explanation there?
well, I figured that it would be like too big of a problem for me to work on at the time.
Mhm.
But actually, I was part of like, even though I was doing Hyperloop and electric racing really hadn't started at the time, but uh, I was involved in this thing called GoFly, and we were trying to build this like uh, if you've seen like the Uber Elevate, like those like personal like flying vehicles, those like the basically it was like basically like a rideable quadcopter.
Kind of like a
Um,
bicycle that starts flying.
yeah, sort of like that scale. So we were working on that for a while, and it was like
I guess
this like
that's what Joby just acquired, right?
maybe
I
yeah.
believe so. Anyways,
Uber, yeah,
so you were on the scale. It had maybe like 4 helicopter rotors,
yeah,
ish rotors. Okay.
yeah, yeah. So what we did was actually what's funny is that one of our early designs like used the same motor from the Hyperloop pod. So there's like a lot of overlap there. Once you're going to that scale where you need like really high performance motors, the options get limited, and you'll see a lot of the same motors showing up. But yeah,
Mhm.
it was like this quadcopter shaped thing where you had like a passenger pod underneath, and each arm on the quadcopter actually had like 2 propellers, so it was like a contra rotating propeller setup, and that was to reduce like noise and increase efficiency. Um,
Nice. So that was at the same time as the Hyperloop competition and the electric vehicle?
that was the same time as the Hyperloop competition, and then after the Hyperloop competition, I kind of got started with electric racing.
Okay. Okay. So yeah, that was what you were focused on during university, building things, making an electric copter. That's great. Um, so there's in the comments right here, 3D printing is cool, but 3D printing metal, this opens up a whole new area for mass
Sure.
producing stuff. So like, let's get into the 3D metal printing. How did you get started in 3D printing? And then how did you decide to start 3D metal printing?
Yeah. So my first experience with a 3D printer was in robotics. The first year we were kind of still doing the sheet metal thing that I learned from like uh, from my earlier years. But
Mhm.
after the first year, we realized like relying on these like kits are it's like really difficult, really expensive. Our robot's really heavy. It'd be really nice if we could get like a plastic 3D printer. So we bought like this CR10 plastic printer. It's similar to like if you're like if you're into 3D printers, like the Prusa printer, it's very similar to that, like where you have like a nozzle and moves around and you have plastic filament that comes through.
Mhm.
Um, and it changed everything for us because we were able to just design custom parts for the first time, and like just with the click of a button, it just would come out after a few hours, hopefully. Um, so yeah, we were able to like design like really complicated mechanisms, and the couple years after that, we were like, so we did. I guess the competitions we did were FTC, which was like the first tech challenge, and then the other one we did was underwater robotics, which is like Mate. There's actually a movie about Mate. I forget what it's called, but yeah. Uh,
About how do you spell that? About MATE?
Mate. Yeah, the movie's called Spare Parts. Yeah.
Okay.
It was a good movie actually. I think George Lopez was in it. But the idea was like making this like underwater like ROV, and almost all of those parts were 3D printed or laser cut. So it really changed like the way we could design things and like what we could do. We actually ended up like having like the side we had like 3 thrusters for moving underwater, and the 2 on the sides were like they could gimbal, and a lot of the hardware for that was 3D printed. Um,
Nice.
and so gimbling so it could like rotate, and like there are very few teams that could do that.
Mhm.
So it really allowed us to like learn a lot, and if the part didn't turn out correctly, we'd fail, but it didn't cost us much. So it was really helpful in the learning process. Um, and then in college, I had briefly for a while, or for summer, I had in fall, I had a job running the College of Engineering 3D printing lab. It was just like a print farm of like plastic printers, and I'd kind of like operate them and like service them, and help set them up. So I did that for a bit and kind of got to see like what like different college or engineering students would be printing on those, and just got to understand like the logistics of operating a print farm. Yeah, and so I think that's where I really got immersed into 3D printing, and I was like surrounded by them. And then I originally wanted to do something. I just knew I wanted to do something in printing. So when I was thinking of like the idea for Vucasan, originally it was like to work on plastic, and actually had like a really dumb name for it. It was called Lime, but I never I never went ahead and made a Twitter account or talked about it publicly or anything.
Podcast exclusive.
Yeah. And the idea was like just how to improve like the rate limits of plastic printers to make them go faster, and how to automate them. So I think that was like where I got started, and then I kind of realized like, okay, I mean, these plastic FDM printers are good, but if I'm trying to do this for manufacturing, it's very hard to get to the point where on an FDM machine you're going to be able to print fast enough to compete with something like injection molding for plastics. It's like the amount of like work it'd take to make that work, like make the machine, and the cost of the machine versus like the value it provides would be quite low. And so I started to look at metals a bit, and it occurred to me like, oh, metal, you don't have to heat metal with a nozzle. And I think that's where I started to think like, because the way plastic printers work is you have like your resistive nozzle, and there's like electricity that runs through that nozzle and generates heat in the nozzle, and then that heat needs to transfer from the nozzle walls into the plastic filament material, and that takes a lot of time. When you're printing metals, generally the metal is much higher temperature, and so you need a lot more power in order to heat that metal up and sync it up with the movement of your motors and move across and lay your geometry down. So the heat transfer actually becomes a huge rate limit for metal printing like that. So I realized like, oh, what if we could produce heat directly in the metal? Like, is there a way to do that? And induction was one way to do it. So the Vucasan printer, what it does is we're basically developing a print head that uses an induction coil to heat up the metal, so that the heat's produced directly within the material rather than like having to wait for the heat to transfer from the nozzle into the material. And so you're able to heat up larger quantities of metal much faster.
And how did you get that insight?
I was just thinking of, I don't know. I mean, it just kind of occurred to me, to be honest. I'm not sure. I did see that someone had used an induction coil to heat up, or for a plastic FDM printer, where they used an induction coil to heat up the nozzle, but not the material, because plastic won't be heated up with an electric field. So I kind of started out that way, and kind of got the idea and stumbled upon it. It just kind of occurred to me. I don't really know exactly what happened,
but then and then okay, so you came up with this, and then you started tinkering around with like making a metal 3D printer, and then you're like, okay, this can actually be a startup. So how did you realize that it can be a startup and scale into something bigger?
Yeah. So I think that let's see. This kind of occurred to me like back in January or like February, maybe March, like really early like before the pandemic happened, actually. And then I kind of dismissed the idea of induction. I was like, there's got to be like, there's got to be a reason why like people haven't done this. Like, it just seems like a no-brainer. Induction is like fairly common. It's not like super obscure within electrical engineering. There has to be like some practical reason for people like not to do this. It seems too easy if you just have to melt with an induction coil and lay down the metal.
On our theoretical, on our calls before, I asked you like, okay, so how are you, going to fail? And you're like, well, if I'm just missing some like dumb technological reason that this won't work. It feels like that.
Yeah, I always thought like, there's got to be some like obvious thing that I'm just not aware of that's like missing. I mean, there's a lot of challenges that I just wasn't aware of early on either, that I kind of discovered along the way. But it was after I dismissed the idea of doing an induction coil, and then I just wanted to read up on just metal printing in general, like the industry, and understanding like, okay, what are the key technologies in metal printing that exist today? Like I saw a lot of press about metal printing like in the past. Why isn't everything metal printed? Like on like startup Twitter, people talk about like software eating the world. Like, why haven't 3D printers and particularly the metal printers, why haven't they eaten like the world of manufacturing?
Mm-hmm.
And just understanding like all those different challenges and problems that like people who actually build things are facing,
And so,
like physical things.
mhm. But even so, like even if you conquer 3D metal printing, that's not going, in your opinion, to completely disrupt all of manufacturing.
Yeah, I think anyone saying that like metal printings, everything's gonna be replaced with a metal printer, um, just doesn't spend much time in the manufacturing industry. It's easy to like read about like like a TechCrunch article and like read about metal printing and think like, oh, okay, this is going to be like this huge thing. And I saw in the article that they were printing rocket engines. They can print anything if they can print rocket engines. Why everyone's just going to print these things, and they tend to overlook the complexity of the manufacturing industry and how like it's really about minimizing cost per part and really improving the manufacturing speed, reliability, and there are a lot of problems that come into it when going to switch to like an additive manufacturing process, which is like the industry term for 3D printing.
But I think one of the best things that you've probably learned, or that you've told me, is that you can be super synergistic with all of these other manufacturing companies. So
Right.
then, for example, our friend Aaron, you can like help him out too. Like you can
Yeah.
make parts for him, and then he can use those for his manufacturing startup.
Right. Yeah, exactly. I think that, so I don't think 3D printing is going to replace all manufacturing tooling, but I do think that 3D printing can be involved in the manufacturing process for any kind of product, especially when it comes to prototyping the manufacturing tooling. And so like manufacturing tooling is like basically you're building the machines that make the machine or make your product or like part or whatever.
That's that's kind of the name of Vucasan, right?
Yeah, so I guess I should explain what Vucasan means. So Vucasan is actually like this misspelled like version of Vucasan, and it's named after Jacques de Vucasan, who invented the all metal lathe. And the lathe is like this machine tool that like, or like this shop tool that you can use to like that spins around. If you can kind of think, like, to explain it, it's like if you've ever seen someone do like pottery with clay and they like spin a like table around and they have the clay and then like form it with their hands. It's kind of similar to that, but you put the material in and then you have like this blade that cuts into it and you can cut away from a spinning piece. And so it's really important about the lathe is that it was one of the key machines that enabled the Industrial Revolution. Like prior to that, lathes existed, but they're mainly used, or even like high precision metal lathes existed, but they're really just used for like watchmaking and like really high precision small parts. And with Vucasan's lathe, what he was able to do was focus on like textile machines and like larger industrial machines. And so like without the lathe, like James Watts wouldn't have been able to invent the steam engine because you would need to make really large parts with high precision and high strength. And so I kind of view like Vucasan as like metaphorically like similar to what Vucasan with his lathe had to do. We're focused on kind of producing like slightly larger parts with really high strength, with really high precision. So I kind of view it like that.
And like just how the lathe enabled like steam engines to be built. Like I was just saying, your additive manufacturing methods can help our friend Aaron with his startup and start doing his like his manufacturing methods as well. So
Yeah.
so it's catalyst for onshoring manufacturing onto America.
Sure. Yeah, absolutely.
Is one way to phrase it. So how did you know that you were like ready to start the startup? There's a question in the chat, Treston. What is the hardest challenge you faced? And I think that kind of comes back to the Hyperloop. If you want to talk about that, like what was so difficult about that, and how did that experience like help you realize that you wanted to be a founder and that it was that was the path.
Yeah. So I think with Hyperloop, like Hyperloop's like it's not just like, I think a lot of people see like the press coverage for like the Hyperloop competition and assume it's like one day. It really takes the span of a year to develop and produce that pod. And generally, like, you'll spend like a good 6 to 8 months designing the pod or designing the pod in CAD, doing simulations, doing like all the electrical design for it. And then you'll spend maybe 2, 3, 4 months manufacturing it and like acquiring the parts and assembling everything. And then you get out to SpaceX and you actually have a full week of testing. So there's like around 130 different tests that you have to pass just to get your pod in the tube. So like there's maybe like 400 or 500, 600 teams that like, submit proposals every year. After the whole like process of reviewing like the submissions and the interview process, it's narrowed down to like 20 teams that are invited to compete at SpaceX. Usually only 3 or 4 actually make it in the vacuum tube. So that testing process is brutal,
Wow.
even for like the top teams. And so
the well-funded, well-organized teams.
yeah. So there's like this one European team that had like, they flew out their pod on a private jet and they were working out of like a private air hangar. Like I think our team's budget was around like $80,000, including all the logistics for travel and like shipping the pod out there and like providing like places to stay for everyone. And
definitely couldn't even use all that to get a private jet.
Yeah, I think the top team, TUM Technical University of Munich, their budget was around like $1.7 million, and their own like building, and it was crazy. Like the European teams are really good. Don't get me wrong, they're really good. But yeah, so competing against them was really tough. But I think what the hardest thing was is that around like 4 days in, we realized like there was just a bunch of mechanical issues that we had in the pod and we needed to fix. We were behind on a lot of the electrical things as well, and electrical testing, because that was dependent on the mechanical testing to pass. And the team wanted to give up, and I really didn't want to give up. I really viewed it like the Hyperloop competition is like this really unique opportunity. We've got this could be our first and last time being there as like competitors. It's not like we just got in this year, and like teams are really competitive. It's really hard to get in the top 20, and I felt like it wasn't good to stop with 1 day left of testing. And even if we know that we're not going to make it in the vacuum tube, that we should keep going to see how far we can get along through the test and like improve our rank.
And even at this point, the engineers who were helping you, they were like, you should just stop. Because you were kind of behind on the test. There like your wheel was messed up. There were some issues there, and the engineers was like, just go and enjoy the city.
Yeah. There's one Boring Company engineer that told us, like honestly, it's really hard. It's honestly just party in LA. You're in LA, just enjoy it. And I hate that. Infuriated me. I was really upset. I didn't say anything, but internally I was very upset. And it felt like we were giving like the losing speech a day before we actually lost. Like, we don't know how far we're going to get. And this is a competition. We're here to win and get as close as we can to winning. And any less is just, not acceptable. And we should continue to work as hard as we can. We've already like spent a year working on this. We've already, during testing week, we've gone through that whole process of being beat up by these engineers and getting through that process and like fixing the pod and changing things and working late hours and like being sleep deprived for a full week. We can hold out for one more day and keep continuing. And I just wanted to continue. And I think that
you guys were like huddled in a circle. Like you guys were like listening to the losing speech. Like your leader was giving the losing speech.
Yeah. I was like, at that point I was in tears, and I quoted Elon, who's like thinking about like, oh, if something's important enough, you do it anyway, in spite of the odds of failure. I gave that quote and convinced a few people to keep working. And then at a certain point, we just kind of gave up mechanically, but on the electrical side, we never gave up. And, it was like, I kept working on some of the soldering, and, a lot of the software people ended up staying up that night and continuing, even though the team overall had kind of folded. And, I think that was probably the hardest, knowing that we didn't, we kind of threw the towel in and gave up early. I was pretty upset with myself for months after. And I realized like, I don't want to be I want to be, from now on, if I'm running things, I want to be in the position to choose when to throw the towel in. And the answer is like almost never.
Yes. And yeah, exactly. So that's how you were like, okay, I need to be a founder. I can't be relying on other people that will quit early. Dude, I think that's an
Yeah.
amazing moment where you kind of just like stood up to in front of the team and was like, well, I'm not a quitter. If it's worth it, you keep doing it. I think I love that story when you first told it to me. Um, yeah, and so now you're working on this. So you're planning to move to San Francisco soon, or are you to, or what's going on there?
Yeah. I mean, we'll see how things go. I still am leaning towards San Francisco, at least for like a year or something, just to meet people. The long-term plan is to be in Long Beach because that's where all the aerospace companies are. And I think that aerospace companies and manufacturing tooling companies are going to be like the biggest customers for metal printers. So it makes
That's
sense to go there.
is that where Delian is with Varda? Is that Long Beach?
Yeah, I think he's like planning on being in El Segundo. I think he tweeted about that being in El Segundo or something,
Okay.
which is in that area, and like SpaceX is there, and like you're like near One Rocket Road.
Yeah,
So
that's the perfect place to be. You know, I've heard that LA is the best place for like certain hard tech companies because you get instant shipping, because you can get
yeah,
parts within hours. So
right, yeah,
Boom, by being in Colorado, is actually having to wait like 1 or 2 days for parts. But in Long Beach, you can basically press a button and you have a screwdriver or whatever you need.
right. So actually, literally right across SpaceX, like next, there's like the Hyperloop tube that runs across runs down the road. Across
Yeah.
that is like this Costco, but it's like the industrial version of Costco where you can like buy mechanical parts. It's
That's
actually
awesome.
like Costco's on the name of the building, but it's for industrial parts and stuff. And then also another reason why LA is a big spot for that is because MasterCard is like the biggest like supplier for mechanical engineering. It's like the Amazon for mechanical engineers, and you can like pretty much order anything, and it's like low cost, and they usually ship like same day or like within a day. It's actually their shipping's faster than Amazon Prime.
Oh
They're
my
better
God.
than Amazon Prime at this. Um,
Amazon, take
and
notes.
yeah, and so there's a McMastercard distribution center in LA, and so that's a huge reason why like you're able to get parts in hours.
Okay. Okay. Nice. So then it kind of just leads to a critical a mass of a ton of hard tech startups. So it
Yeah,
seems like LA is much better than SF to if you're a hard tech startup is kind of the vibe that I've gotten at least.
yeah. There's a couple companies like I mean you also have like you have Vandenberg Air Force Base, which
Hmm.
is in Southern California. You also have like Anduril and like other companies like that in LA. So I think that I'm pretty long LA, but we'll see.
What now? This is kind of like just I kind of just want to start asking like some random questions. Like, what did you think of the Blue Origin landing the other day?
I thought it was pretty cool.
Anything?
Like landing's hard.
I guess it was kind of off center.
Yeah.
I want to talk about like something. What do you think about like any space manufacturing projects that interest you?
I think what Varda's doing is very interesting.
Mhm.
From
We
and
can't we can't say
yeah,
exactly what they're doing.
yeah,
That's
yeah,
not public.
yeah. Um, yeah, but I think what they're doing is really cool. I think manufacturing things in space that uh, you couldn't otherwise produce on Earth, and then selling back to Earth is like a pretty interesting model, and they think that
Mhm.
that'll work pretty well, especially with the falling cost of launches, and I think that we'll see more of that.
Man, I wish you could come out for the Starship SN9 launch.
Yeah, isn't that on like Monday or something?
It should be happening Monday, Wednesday, something like that. I'm gonna be back down there, so I was down there for the SN8 launch, or the SN8
Yeah,
crash, and then I figure I have to be there for the first time that it actually lands, and I think
right.
that this time it will land. What do you think? What are your odds on that?
Uh, I mean, I think they've probably learned a lot. What was the issue with the like? Wasn't it one of the like Raptor engines that didn't fire correctly on the landing burn?
Yeah, yeah. It was something to do with the header pressure, so it just didn't have enough like thrust, I think. So it just didn't have
Yeah,
enough thrust to stop it from going.
right. And then like the big thing with that test was just seeing how they could air brake with the flaps, and like proving that was,
It was
like the really hard thing, right?
yeah, it was really weird to see how like slow it fell. It felt like it was just not falling at all.
Yeah.
That was super strange. I guess that's, that's part of it. That's the design. That's how they're going to land on Mars. What? Yeah. Okay. Do you have any interesting opinions on like when we'll have humans on Mars or anything like that?
Well, I think that it'll happen in the next maybe 10, 15, 20 years.
Yeah.
Yeah, it's like closer than I think that most people think. I mean, it's not like 2, 3 years away either.
Mhm.
I think honestly, like a lot of the technology to get to Mars is already there. It's just like um, we're kind of doing like scale tests, like let's go to the moon first and other things just to prove out all the systems. I think a lot of this is like the transportation stuff's there. It's like how do you live and sustain a colony on Mars or like a small settlement on Mars, which is much harder.
Mhm.
So I think we'll have people on Mars soon.
I hope so. I think so too. Cool. Do you think that does the chat have any questions, or do you think that there's any questions that I should have asked you? Otherwise, I think we're coming up on like 45 minutes.
Got
So
it.
that's like a
How long
decent.
do you
I don't
want this
know.
to
I'm
go for?
I'm learning
Okay.
like I'm kind of learning if what I want the format to be. So like I think in the beginning of this podcast or episode, it was like, I was asking you very specific questions about Vucasan, and then for the last like 5 minutes, I was just kind of like riffing and asking you like I don't know about space and Mars and stuff like that. So I'm definitely still learning the format. I am just trying to figure it out if I want to be more pre-planned or if I want to be more riffing, more, maybe Eric Torenberg versus Joe Rogan, stuff like that. Um, so yeah, basically just still figuring it out.
Got it.
Rob
Yeah.
asked, "What's your favorite movie? Is there any engineering movie that really inspires you still? Maybe as much as Iron Man used to."
I would say that I think a lot of there's like 3 movies I can boil it down to. And actually I can keep going for like a little bit longer if you're free. And maybe I can talk a bit about manufacturing and some of my opinions there.
Yeah, go for it.
But yeah, I think my favorite movies are Interstellar. That's like one of my favorites. I also really like Ford versus Ferrari. That was an amazing movie. And I really like that one because I could kind of relate to like the competitive aspect of that, and it really felt like one of those movies that had a lot of heart. And you could tell like I'm a huge fan of Formula One and racing, so it's like really fun to see that. And then of course Iron Man was my favorite childhood movie, and it still is one of my favorite movies. I think I've seen
Of
it like
course.
15, 20 times.
Of course.
Let's see, actually, there's a question about like advice for a student entering college as a mechanical engineer next year. I'd say that really just get involved in a student engineering team and put as many hours as you can in there. I would say like I'll give advice for learning because I wouldn't consider myself a great student. But if you're looking for learning how to be an engineer, I think that student engineering teams are great because first of all, you have a pretty big budget to play around with. Usually somewhere between like $30,000 and $100,000, which is more than you can mess around with on your own as just like a hobbyist. And then it's also, I think, better than like interning somewhere in some ways because at an internship, you have mentors that prevent you from failing and prevent you from making real mistakes. Your mistakes will be caught before you go ahead and build the thing or you prototype the thing or whatever project you're doing there. Whereas within something like FSE, which is like the Formula Student competition, or like, well, the Hyperloop competition is not around anymore, but there's the boring competition. That's another really good student one. There's also RoboSub, which is like this underwater robotics competition. That's like autonomous robotics underwater. I think like doing one of those 3 is like really important because there, if you screw up the design, like what you build will actually fail. Either you don't pass inspection or it actually like just stops working, like during the competition. And you can learn from that, and you can experience like the psychological pressure of knowing like, okay, you're ultimately responsible for this to work or not, and when things get hard, are you going to quit or are you going to keep going and try to figure out what the problem is and not complain? And going through that is like a trial that I think that every engineer, not even mechanical engineer. Like you could be electrical software. I think it's just like really awesome to do that.
Nice. So actually, I get this question a lot. Would you go to university now? Would you go back to university knowing what you know?
Knowing what I know, if I could do it over and I had to go, I would go to Waterloo if I could get in. But it seems like everyone I've spoken to from Waterloo is just super fun.
Something in the water.
I don't know what it is. Yeah. I do think that, let's see. I mean, you can get access to facilities that you wouldn't have access to. It depends also on, I think, how much money you're spending. I don't think it's like worth spending hundreds of thousands of dollars to like go to private school or anything. I think that if you can get into a good state school, and you're still kind of trying to figure things out, then maybe college is a good option. Now, if you're like, if you do a lot of like open source projects and like you're good at like working on your own independently, and like have aspirations for doing a startup, and you feel like you have the skill set to do the startup, and can like manage that kind of pressure, then maybe you should go do that instead. It's hard to like put out some general advice. I think that generally, I think that college is overrated. The learning you can get there isn't as great as just doing your own thing. If you really think about it, let's say you spend like you have like maybe $15,000 saved up for college, or $20,000 saved up for college. I think honestly, you'd be better off just like spending that on tools and parts and like going and building something really cool. And I think that the barrier for even like mechanical engineering isn't as high as you think it is. You can get access to like all the CAD software you need. You can basically, like, if you have something you need to design, you can use an online service to get that machine or like metal printed or 3D printed. And like, honestly, the plastic 3D printers are really cheap and reliable these days. You can get a really good one for $300-400 and it'll do anything you need it to do, for like a project. And with microcontrollers like Arduino is what I had, but like now I think these days it's like Raspberry Pi or like the Teensy microcontroller. Like those are like really cool microcontrollers that you can mess around with and you can do a lot with them. And so I really think like if you spend like a couple $1,000s on just a project and like building that out, you'll learn tons more than anything else. Yeah.
Nice. So going back to your manufacturing, what are your manufacturing opinions? Like, where should I start asking you a few questions on that?
Yeah. I mean, we could talk about how,
Go ahead.
I was gonna say maybe we could talk about how I think 3D printing was overrated.
Go for it. I love that from a 3D printing startup founder.
Yeah. I honestly thought that. So I think that generally when you read press coverage about printing, it's just incredibly like overblown. The claims are overblown. People tend to come away with thinking you can just make anything. Complexity is free. I can make whatever geometry I want and it'll just work. And that couldn't be further from the truth. Like, especially with metals, there's tons of labor and post-processing that has to go into making your part. Generally, you have a raw part that you have to make. And then like after all the post-processing you have to go through that, you're losing several hours of operating time. Generally, you have to design the part in a way that can be suited towards printing. I think that there's just a lot of difficulty there. And so people just underestimate how much time and like effort it takes to like make metal parts. I think that's one reason why printing is terrible. Another reason why I think printing is like really awful is because I think what people don't understand is that you can't just take an existing design and print it. In the real world, the way manufacturing is done is you basically design the part knowing the manufacturing method in mind. Like the parts have to be designed for manufacturability, otherwise they won't be built at all. Otherwise it just stays as a CAD model on your computer. And so you can't just take an existing part. Like, Tesla's not going to take their, their like Model 3 chassis and just print it on a metal 3D printer. They have to prototype with the machine tools that they have. And so there's like this huge process of prototyping the machine tools they have to go through. And that's what kind of confines like the limits of what's going on. Like a lot of people in tech talk about stagnation. And this is kind of tied in. Like I think a lot of people talk about stagnation in tech, and you could say largely it's regulatory. I think it's just too easy for people to rationalize that, oh, we shouldn't build this thing because it's too hard or expensive to manufacture. And so if you don't solve that manufacturing constraint, or at least get rid of that excuse, you're not going to solve stagnation, because it's really hard. It's really easy for people to rationalize yourself out of building something. It's like, oh, this is like a little too hard to manufacture. It's not practical. Think about the feasibility. I hate the word feasibility. It's important, but it's also one of the most annoying words. So I think that with metal printing, what it allows you to do is, or at least hopefully what it allows you to do is iterate on your part. And so you can kind of treat it like with software. What's nice is you can type your code, run it, and then it breaks, and just like change a few things and keep running it. And that's how you learn. There's like this feedback loop where you can learn really quickly and like make really cool things quickly on a computer. It's not true in the world of hardware and in mechanical engineering, because with the part, you spend hours making the part. The design's the easy part. Making the thing's like way harder, and it costs money, and it's really annoying. And so I think the goal is to make metal printing, first of all, it has to be low cost enough. It has to offer like high strength, but it has to be easy enough to operate that you can essentially just take your design, print it out, and you're able to like see, oh, it didn't work. Let's see what changes I have to make to the part in order to make this like functional. And you can iterate really quickly. And I think that if you can iterate quickly on metal parts, then it can do a lot for fighting stagnation. Because now, in the like big aerospace companies, a lot of times it's like you'll have an argument in a meeting talking about, okay, do we really want to change this part, or can we just make like a small incremental improvement? And with a metal printer, you don't have to like develop new machine tools to build that part. You can just print it on a metal printer, and if the part or if the printer you're using can produce parts at a low cost and quickly with minimal post-processing, then you've kind of gotten rid of any excuse for like not making progress with your parts. Like now you can iterate and start from scratch and keep changing the design.
Nice. Okay, man. I think that's basically all the questions I have for you. Do you have it? What do you want to shout out?
Sure. Just if there's any question, I know there's like a ton of questions I kind of like read about but didn't answer. Just DM me on Twitter and I'll answer them, or like just tag me on Twitter and I'll answer them. I think my Twitter handle is in the YouTube description. Just go ahead and reach out to me there and I'll answer any questions.
So definitely go follow Dival on Twitter, and go check out his startup, his website. And if there's if any VCs or anybody is listening to this, what are you going to be raising at for your pre-seed or seed?
I don't know what valuation I'm raising at.
You don't know exactly, but you're going to be raising soon.
I would say around March.
Yeah, that's what I was going to ask.
With COVID, things change, but so maybe things can change. But I think around like late March probably is when I'll probably start taking this. But I'm always happy to start a conversation and establish a relationship with an investor up front. It's cool to be friends.
Awesome. Yep. So definitely DM Dival if you have questions about being an engineer and starting a startup, or if you're an investor as well.
Yeah.
Go follow me on Twitter at NASJAQ and subscribe to the podcast. And I really appreciate you guys for taking the time and tuning in. And I'll see you guys next time. Peace.
All right. See ya.
Awesome. Thanks, man. Good night, man.
Bye.